Example 5 says, find the indicated term of the geometric sequence. So it doesn't even tell you need the formula yet, but obviously we do need the formula to jump to the 10th term. So we're going to find the formula, then we're going to find the 10th term. So what's different this time is that I have the first term and the fourth term. I can't figure out just yet what what R is, right? So there's a couple ways to do it, but one way, and it's important to understand the manipulation of the equation, is if you take what you're given, which is a sub 4 and a sub 1, and you put the larger base on the left. So I'm going to say that a sub 4 is one of the pieces of information I have. I also have a sub 1. Now my normal equation would be r to the n minus 1. So if I think back to if I'm finding, let's say I'm finding the second term, this would be whatever a sub 1 is times r to the 2 minus 1, which is 1. If I was finding a sub 3, it would be a sub 1 to the r 3 minus 1, which is 2. If I was finding a sub 4, it'd be a1 r 4 minus 1, which is 3. So what do you notice about the relationship between the numbers on the right side and the numbers on the left side of these? So if the bottom is 1, it's always, the exponent is always 1 less than it, right? If I change that exponent, which you can, you just have to make sure that these two numbers here add up to this one. This number plus this number has to add up to this one. This number plus this number has to add up to this one. So after it's subtracted 1, okay, after you've simplified the exponent, you would want them to add up to the one on the left, which means you can jump from 1 to 4. You just have to make the exponent what? What would I have to add to 1 to get to 4? 3. So I can actually use this equation. You can jump from whatever term to whatever term in a geometric sequence by changing the exponent on the r, so that the base on the number on the right plus the exponent on the r add up to the base on the left.
So you don't have to go through the whole process of subtracting.
Correct. So now plug in what you know. I have a half on the left. I have a sub 1 being negative 4 times r to the third. So what I don't know is what r is. I'm going to solve for r. So I'm going to take and divide both sides by negative 4. Dividing by negative 4 is the same thing as negative 1/4. And I get negative 1/8 equals r to the third. So now I get r to the third equals negative 1/8. How do I get rid of a third exponent? Cube root, right? I'm going to cube root both sides of this. So cube root of r to the third, cube root of negative 1/8, negative 1/2. Now I have r. So now if I want to go to the 10th term, then a sub 10 would equal a sub 1 r to the n minus 1. So a sub 10 would equal negative 4 r, which is negative 1/2, to the 10 minus 1. So negative 4 times negative 1/2 to the 9th. Now remember, the exponent is only on the 1/2. So even if I gave you a calculator here, I don't want a decimal there. I want an exact number. So this should be negative 4 times negative 1 over 512. And then simplify that, and I get 1 over 128. So the danger of the calculator there is you'll rely on it to get a decimal, and it will be wrong. You need to make sure you can use it. You can use it to 2 to the 9th and get what that is, but then you need to make sure you keep it exact. Questions so far? So I also had the choice of going from a sub 4 to a sub 10 there, because you can use any term, right? You just got to use the exponent on the r to make up the difference. So if I'm going from 1 to 10, then the exponent's going to be 9, because that's the difference between the first term and the 10th term, right? But let's say I wanted to use the fourth term. So the bigger one goes on the left. I'm finding a10. Then it would be a4. R would have to have what exponent? 6. Does that make sense? So now I would get A10 equals, I would use A to the fourth, which is 1/2, and then I would do R, which is -1/2, to the sixth. I would get the same answer. So you can use the exponent to make the jump happen. Does that make sense? Yep.
But either way, you just have to find R again.
Yeah, to begin with, you've got to know R. Yep. You've got to know a starting point and the R. And so if you don't have the R, they're going to give you at least 2 terms to figure out what that is. All right, so this one says, find the indicated term of the geometric sequence. This time I have A sub 2 and A5. I don't even have A1 this time, right? So use that, what we just talked about, to find that jump. So which of these is going on the left, A2 or A5? A5. So A5 goes left, equals A2 times R to what exponent? Third, okay? Remember, the base and the exponent have to add up to the one on the other side. Does that make sense? You actually could have switched that, but your exponent would have been negative. I wouldn't have done that. Now plug in the information you have. So 2/3 equals -18 R cubed. Divide both sides by -18. Yep.
Wouldn't that be 4? Yeah, R to the third. Because it's 5 minus 1.
You need the base on this one and the exponent to add up to the one on the other side. Normally we do n minus 1, but we're already skipping that step. Does that make sense?
Yeah.
Okay. So then this would be 9 -1/27 equals R to the third, and then cube root both sides, and R equals -1/3.
So then after you find R is pretty much when you can make your own decision of whether to use A sub 2 and then A sub 5.
Correct. So if I have R and I need to get to the sixth term, there's really kind of like 3 ways to do it. What's one way to do it?
Just take A.
Just multiply C by 5.
Which is probably the easiest. Take my -1/3, multiply it times A5. Does that make sense? So I would get 2/3 times -1/3, which is -2/9. Because I only needed to go one more term past the one that was given. If you needed to skip a bunch of terms, then I would have said whatever I'm trying to get would be that number here equals whatever number I want. That's the closest or the furthest. It doesn't matter as long as the R with the exponent makes up the difference so that this plus this equals this. So you could have also got this answer by saying A6 equals, let's say, A5 R1, or A6 equals A2 R4. And then plugged in the A5 and the R, and plug in the A2 and the R.
Can you use a different place to check?
Yep. So if you've got extra time, you can use it more than one way. Should get the same answer every time. Does that make sense? Questions? All right, now we're going to talk about sums. So we talked about the sum of a generic series, the very first section, where if you were finding the sum from 1 to, let's say, 5, you took 1, plugged it in, 2, then 3, then 4, then 5, and added them all together. Then we said, what do we do if it's arithmetic? And this was the n over 2 times first plus last. Now we're talking geometric. So geometric would be in a format like this, okay? It's going to have a to the first times r to the I minus 1. And you will know the difference between a and r because r is going to have the exponent. A will not. And then the equation for the sum of the geometric series is a sub 1 times 1 minus r to the n over 1 minus r. The other thing this says is that r can't be 1. Okay? Obviously, that there's no growth there. So now we've got what? Formula for a sub n for arithmetic, sum for arithmetic, a sub n for geometric. Now sum for geometric. We're going to have one more after this. All right, so it says find the sum. So a sub 1 times 1 minus r to the n over 1 minus r. Now you got to figure out what part is what, right? So what part of this is a sub 1? 32, the number that's not raised to the power, right? What part of that is r? 1/4. And what part of that is n? 6. Remember, if the number on the bottom is 1, the number at the top is your n. All right, then plug it in. So 32 times 1 minus 1/4 to the 6th over 1 minus 1/4. So I get 32 times 1 minus 1 over 4,096 over 1 minus 1/4. This is when it gets fun, right? Now I got to change those so they have a like denominator. So this would be 4096 over 4096. And this would be 4 over 4. So 32.
How'd you get to the fourth power?
Say that again.
How'd you get to the
Oh, that's a 6.
I mean, 6 power.
That's your n.
So the n is the top.
N is the exponent on the r, yeah. Oh, yeah, yeah. The n is the top of your sigma.
If it was like I equals 0,
Then you would be 7.
I mean, yeah.
Yes. So if the number on the bottom is 0, then you're doing 7. You're adding to it. Okay, so then this is 4,095 over 4,096 over 3/4. Then I want to flip these. 4,095 divided by 3 is 1,365. 4,096 divided by 4 is 1024. So I've got 32 times 1,365 over 1024. And then I can either multiply all my numerators and then reduce it at the end, or reduce it beforehand. I would recommend the beforehand. 1024 is actually divisible by 32. It goes in 32 times. So I'd get 1,365 over 32. Yep.
So is there a chance we'll get like weird like fractions like that on the quiz?
Sure. I won't make you do 1/4 to the 6 without a calculator. So it'll either be a smaller number, or you'll get your calculator. I'll let you know tomorrow for sure, one way or the other. But be very careful, because notice the only time I really used the calculator there was that 1/4 to the 6th power. I don't want you to put decimals in here. It will make it, you'll end up rounding, which makes it wrong. Okay, it has to be kept exact. Questions on sum of a geometric? Okay, so be careful with this, because even if a question says, let's say it says this. And you're trying to find the sum of that, right? Is that a geometric sequence? Would a 4i be geometric? Yes, it would be a geometric sequence. You with me? Because you'd be multiplying it times 4 every time. But is this in the same format as that? No. So you'd either have to put it in that format, or you would plug in 1, plug in 2, plug in 3, plug in 4, plug in 5, plug in 6, all the way up to 10 and add them together. Okay? If it is like that, the number's not going to be 10. I won't do that to you. But just so that you'd realize that you can't use that formula if it's not in that format. So it has to be as something, a number, right? And then this would it would be like that. Something like that. Okay? That's how you would know that's in geometric. It would have the exponent on it.
Because the other ones are like what we use with the other one.
The very first section, where you would just take 1 and plug it in, then 2 and plug it in, then 3 and plug it in, then 4 and plug it in, and then you'd add them all together at the end.
This one, the geometric, you have the exponent.
Correct.
How'd you get 32 times 1,365?
So I'm going to show you how to do this in your calculator again, just for checking purposes. If you're able to use a calculator on this quiz, it will not be graphing. All right, but standardized test, obviously you can use this sucker. So if I wanted to type in that sum, remember that math all the way down to 0 is where summation lives. Then I put in whatever variable I'm going to use, which this is just x, is that just represents your variable. The bottom there says x would be equal to 1. And then I could arrow over the top. This time is 6. And then I'd arrow over. Now this is what you got to be really careful about. I have to do 32. I have to open my parentheses. 1 divided by 4. Close those parentheses. Raise it to the x minus 1. So that it's written like that. So what's important is that the 1/4 is the thing with the x minus 1, right? Not the 32. You got to separate it out. And if I hit enter, I get 42.65625. So if I was using this to check this answer, which is 1365 divided by 32, I get the same answer, 42.65625. Okay. So summation is in there. Summation with infinite is kind of tricky. You can't put an infinity in there. You could put something like 999,999 and it will get you close. Or E99 will get you close, but it's not going to get you exact. So again, if you wanted to use that to check answers, that's how you would do it. Obviously, I would make sure I could do it without that because you won't have it for your test or quiz. Yep.
How do we get there again?
That menu. All right, example 8 says use summation notation to write the sum. Okay, so we got a list. This is the same kind of question. The delivery of the information is totally different, okay? I am given something that goes from 7 to 896. I don't know how many terms are in the sequence. So right now, I know what a sub 1 is. I know what the last term is, and I don't know anything about the number of terms. Now, this is kind of a special case because first you want to see if it's geometric or arithmetic, right? If they were all blended in together, I would test. So if I take 14 and divide it by 7, 28 divided by 14, do I get the same number? Yes, what would R be? 2. So this is geometric. So we're going to work it out as though it's geometric because we're in that section. But if I take 14, subtract 7, and 28, subtract 14, do I get the same number?
Yeah. When I subtract 14.
No, it skips, right? So be careful. If they, and there are times where they're both. If you think about 2, 4, 6, 8, 10, they are both. And you could choose, but this is not. Does that make sense? If there was a 21 in there, now it would be arithmetic and not geometric. So just be really careful. Okay, so we've established this is geometric. We've established that we have a sub 1. If I want the sum, I need a sub 1. I need 1 minus r to the n and 1 minus r. So I have a sub 1, which is 7. I have r, which is 2. What I don't have is n. How many terms are in that sequence? You have no idea. Does that make sense? Okay, so what you can do is use your equation, the a sub n equals a sub 1 r to the n minus 1, because what you can have is the last term, 896, the first term, the r, we just don't know what n minus 1 is. You with me so far? Okay, so how would I solve that?
You get 14 and divide 896.
So you can't multiply 7 by 2 because 2 has that exponent. Divided by 7. So 1, 2, 128. Now what?
You just have to assume it.
Hmm?
You have to just figure out what 122 times what is 128.
2 to what power, right? Yeah. So there's different bases, yes? We're going back a couple of chapters. If it's different bases, how do we do it?
Oh, you take 128 and make it 2 to something.
So I got to figure out what power of 2 I would have to raise to get to 128, yes? Remember 1-to-1 property? Okay, so I'm going to break 128 down. This would be 2 and 64. This would be 2 and 32. This would be 2 and 16, 2 and 8, 2 and 4, and 2 and 2. That is 1, 2, 3, 4, 5, 6, 7 2s. So 2 to the 7th equals 2 to the n minus 1. And once the bases are the same, I can set the exponents equal to each other. And I get n is 8. Now I have an exponent.
But isn't the question just write the sum?
Yeah, sorry, but we haven't even written the summation notation. So you would have to have done, so the summation notation would be I equals 1. You'd have to know the n either way to get the number at the top, right?
Oh, okay.
And then a sub 1, which is 7 times 2 to the n minus 1. So this would be summation notation, but we'll continue to go, and so that you can see what the answer would be if it actually asked you to find the sum.
So would it be I minus 1?
Oh, yeah, sorry, I switched the variable. So then I'd get 7 times 1 minus, so 128 times 2, 256 over 1 minus 2. 7 times negative 255 over negative 1. 7 times 255. 1,785. Say again?
How do you get 256?
That's 2 to the 8th. So I knew what 2 to the 7th was. I just multiplied it one more time. Right? 2 to the 7th was that 128. So just double it again. So this is the summation notation. This is the actual sum. So the hardest part sometimes is figuring out what you know and what you don't know, and then how to figure out how to get what you don't know. Right? Because it's going to be different ways. It's going to be delivered in different ways.
So the sum is 170.
Correct. Questions? Last thing in this section, which is the last thing that'll be covered on this quiz, is the sum of an infinite series. So how you would find the sum of an infinite series can only work if your r is a fraction between 0 and 1. Okay? You cannot do this if r is 2. You can't do it as r is 4. But what happens is when it's a fraction, the higher the exponent is, the smaller the number gets, and it kind of counterbalances with the beginning numbers to give you one sum. So you can actually find the sum of an infinite series, a series that doesn't end, okay? Which in theory is kind of crazy, but it only can be done if the r is a fraction between 0 and 1. So that's the first thing you're going to check for is r, when in absolute value, so the sign doesn't matter, it can be positive or negative, is that a fraction between 0 and 1? Not just a fraction, because it can't be 3 halves, right? 3 halves would be bigger than 1. Sarah, did you have a question?
No.
Okay. Okay. If it is between 0 and 1, once you find the absolute value, then the way you would find the sum of the infinite series, and infinite you'll know because it'll have a little infinity at the top, would be by a sub 1 over 1 minus r. This is actually a heck of a lot easier than the ones we just did. Now your question will either be given to you in this format here, where I is 0 on the bottom and the I is, it's raised to the power of I, or it will be given to you the way that the last ones were, where it's still infinity at the top. But this is I would equal 1, a sub 1 would be times r I minus 1. So you don't really have to worry about changing it. Just realize that either of those would result in the same sum. It's just the format in which you're given the question.
So whenever it's the fraction between 0 and 1, it's always the infinite formula?
No, the infinite's going to come from the symbol at the top. Is that going to be a number where you'll use the last one?
No, I meant like if it's between 0 and 1, you always use this formula.
It's not if it's in between. Oh, you mean like can you? You use this formula if it's if the upper bound is infinity.
Oh, it'll tell you. Okay.
Right, and then only can you do it if it is already up to infinity. If this not a r is a number between 0 and 1 once it's in the absolute value. M.
If it gives us, like, if it's saying, like, we have to do, like, a sum of, like, infinity, but r isn't, like, a half.
You can do it.
So you can't do it?
Yep, you would just say you can't do it, which is the directions you see like on the next one. It says, find the sum of the infinite geometric series if possible, and if not possible, explain why. So if that number was not negative 1/2, if that number was 3 halves, I would say it's not possible because r is bigger than 1, or the absolute value of r is bigger than 1. Okay?
It has to be between 0 and 1? Like, r.
The absolute value of the r has to be between 0 and 1. Yes. Okay, so formula is a sub 1 times 1 minus r. Oh, I'm just kidding. I'm writing the last one. Formula is a sub 1 over 1 minus r. That's my infinite sum. So now from this piece of information, I know I'm doing it because it's infinity at the top. Then I'm going to check what r is. What is r in this equation? Negative 1/2. So is the absolute value of negative 1/2 in between 0 and 1? Yes, so I know I can do it. Okay. What would be a sub 1? 5. The number that is not being raised to the exponent is your a. Okay. So now I put 5 over 1 minus a negative 1/2. That becomes 1 plus 1/2. 5 over 3/2. Keep, change, flip. And I get 10/3. If you give it to me as a rounded decimal, it will be marked wrong. Be careful.
And so 10/3 equals like what
That's the sum of every number from 0 to infinity. If my r is negative 1/2 and the first number is 5. So it's an infinite sum. Questions? So a couple of variations to be careful with. Okay, I know a lot of people get hung up on if it says this. What part of that is a sub 1? 1, okay? So if there is not a number that is being raised to a power, then my a sub 1 is 1, and it's going to happen. So just be careful. The one that is being raised to the power is the r. The one that is not is the a. If you think about it, if I took 0 and plugged it in to be the first term, I'd get negative 1/2 to the 0 power, and anything to the 0 is 1, right? That would have been my first term. Questions? Yep.
Can you go back to this example 7?